So we're going to have a look at another question. This one comes from the 2020 HSC Standard 2 Maths paper. Standard 2. So this is question 19. This is a long worded question. We're told a fence is to be built around the outside of a rectangular paddock. An internal fence is also to be built. The side length of the paddock are x meters and y meters. Side lengths are x and y, as shown in the diagram. A total of 900 meters of fencing is to be used. Therefore, 3x plus 2y equals 900. The area A in square meters of the rectangular paddock is given by the formula A is 450x minus 1.5x squared. The graph is listed. If the area is 30,000 meters squared, what is the largest possible value of x? So we can read this off the graph, in fact, because we have a graph. It sort of looks a little bit like this. 30,000 along the y-axis. We trace that across. We find two intersections. One is a smaller value of x, one is a larger one. From the graph, the smaller one is about 100. This is not to scale, this is just my little drawing over here. The second one is about 200. So therefore, what's the largest possible value for x? X large is 200. In order for this to be the case. Now we have two more questions here. Find the values of x and y so that the area of the paddock is as large as possible. Okay, so this is part B. So this curve, this parabola, gives us the area as a function of x. And we can see from the parabola that it passes through 0 on the x-axis over here and 300 over here. Because it's symmetrical around its center, that means its maximum must be at 150. So the maximum height of this upside down parabola gives us the maximum area. So therefore x equals 150 is the x dimension that gives you the biggest area. We've also been asked to find the y dimension. We were told in the question that 3x plus 2y is equal to 900. So we're going to let x equal 150. 3 times 150 plus 2y equals 900. 3 times 150 is 450. 450 plus 2y is 900 minus 450 from both sides. This gives us 2y is 450. Divide both sides by 2. This gives us y is 225. So x is 150 and y is 225. These are the dimensions which make the area of the paddock as large as is possible. So these are the two values that we're after. One we got from the graph, one we then calculated using a given formula. In part C, we're told, using your values from part B, find the largest possible area for the paddock. Well, we can sort of read it off the graph. It's going to be about 33,500 or something like that. But we do have a formula for this. The question told us the area is 450 times x minus 1.5 times x squared. So we can calculate this exactly using x equals 150. So we get the area when x is 150 is 450 times 150 minus 1.5 times 150 squared. So we'll plug this all into our calculator. 450 times 150 minus 1.5 times 150 squared. This is 33750. So therefore the largest possible area that this paddock could have is 33,750 square meters. So this is meters squared. X and Y up here, of course, are in meters as well. So this is the answer to part C. In terms of the marking is reasonably straightforward. For part A, if you identify that the largest x value is 200, you get the mark. In part B, you'll get one mark for finding one of the values and the other mark for then using the formulas to find the other. Note, you'll very likely need to actually use the formulas to find the other one. Reading the values off the graph you really can't read the values off the graph. You do have to calculate here. And then for part C, you'll need, the area is 33,750 meters squared. So this is how we did this question.